All right, problem 25. So we're going to let G be a group and show that the identity element is unique, and then we'll show that for any element, the inverse is unique. All right, here's our group axioms, and that's what we're going to use. They haven't changed. So how do we look at this? And this is where group theory and abstract algebra starts to lose some folks, because we got just a lot of letters flying around, and we got to make sure we know what we're doing. So the question says, if there's an element in G that acts as the unit element, then F equals E. So remember, E is our official certified identity element of the group. F, we're saying, is an imposter. Okay, so we're going to let there be an element in G. Okay, this is G, any group, such that this equation holds. Well, where did I get that equation? I took it from number 3, axiom number 3 about being a group, right? We're saying, what if F acts as an identity? Well, that means that A times that element, that imposter, equals E. And same thing with F times that imposter, right? So all I've done is put F into the equation for the identity. And what I want to show is that F equals E. Now, E, the true identity element of this group that we know exists by definition, well, it certainly has this equation. That's the definition of E, right? So what we've done here is we've said, okay, let's just acknowledge that E exists. So for any element, I'm calling it B, any arbitrary element B, we do have this true identity element. And the question is, can we combine the start equation with the underlined equation to show that E equals F? And all the ingenuity and thinking here is, well, A is an arbitrary element in our first equation, so let's just plug in E for A everywhere we see it. And then we have that B is an arbitrary element, so let's just plug in F, right? F is a member of the group, so we're allowed to do that. Same thing with E above. And that's where we get these two equations. So the first one is where we plugged in E in the start equation, and then the second one is where we plugged in F in the underlined equation. And we have, if we notice here, the only thing we have to realize is that we have that F star E is in both lines, right? So if F star E is equal to E, and F star E is equal to F, well, that means that E is equal to F. So that's how we know that if there's any element that acts like the identity, it's indeed the exact same identity. So all to say the identity element in a group is unique. Now what about the inverse? So part B says given any element in G, we want to look at the inverse of that element, and we say that it's unique. So now we're going to look at part 4 of our group axioms, which says that there's always this element. Here in the definition it's written as B, in the problem it's written as a to the power of -1. So again, we're going to say, well, what if there was a imposter? So I call it C. So there's some element in the group C such that this equation, which again we get from the inverse axioms, it's just copy and pasted, A star C equals C star A equals E. If this imposter does work, we want to prove that C actually equals A to the -1. Now we know, because this is a group, that there is a true inverse, right? This is the exact same procedure, but it's another example. So this true inverse, which we're calling A to the power of -1, definitely this equation holds. 100% it has to in order for G to be a group, which we're assuming is true based on the problem. So now the question again is, how can we substitute or play around with this, or what do we have? Well, last time we plugged in elements, but here we don't need to do that. So we already have that both of these equations equal E, right? We have E on the right-hand side of both equations. So what does that tell us? Well, we have C star A right here, and we have A to the -1 times A right here. So we know that these two elements circled in blue are equal to each other because they both equal E. And that's what we've done here in the first line. And then we've also seen in previous videos that we can cancel as long as we do it on the correct side. So here we cancel out on the right-hand side of both, and we get that C equals A to the -1. Thanks for watching this video. I hope you enjoyed it. Make sure to subscribe so you don't miss out on future videos. And if you have a question about this problem, or if you'd like to request a solution to a different problem you're working on, let me know in a comment below.